Hi students, our next topic is block diagram from the first module of control system. First of all, what do you mean by a block diagram? Usually a control system may consist of a number of components and usually we use diagrams called the block diagrams to represent those components. And a block diagram of a control system is a pictorial representation of the functions performed by each component, and it represents the flow of signals also. And usually the elements of the block diagram are block, branch point and summing point. That means in the block diagram it is constructed by three components. Those components are block, branch point and summing point. Coming to each term, first of all block. And in a block diagram, all system variables are linked to each other through functional blocks. And a block is a symbol for the mathematical operation on the input signal to the block that produces the output. Usually, the transfer function of the components are usually entered into the corresponding blocks and which are connected by arrows to indicate the direction of the flow signals. And the arrowhead pointing towards the block indicates the input, and arrowhead leading away from the block represents the output. And if there is a figure and it shows the functional block diagram, input A is shown which is represented with an arrowhead, and block represents the transfer function g of s of the system, and output is the b. So we can write b is equal to input into transfer function, that is equal to a into g of s. And next is the summing point, and the summing points are used to add two or more signals in the system. And the figure shows a summing point. Usually it is shown with a circle with a cross in the symbol, and this cross represents the summing operation. Usually a plus or minus sign is at each arrowhead is represented in the summing point, and this indicates whether the signal is to be added or subtracted. So the summing point diagram is shown in the figure, and here it is shown that there is a cross inside the circle, and A and B are the input, and the symbol associated with this plus and minus, so output will be A minus B. And next is the branch point, and a branch point is a point from which the signal from a block goes concurrently to other blocks or summing points. And figure also shows a branch point, and from that point the signals are split into various paths. And here at the point A, the signal is split to one goes to the transfer function G, and other goes to another path which is at point A. Okay. So next is a constructing block diagram for control system, and a control system can be represented diagrammatically by block diagram, and the differential equations governing the system are used to construct the block diagram. First of all, we will write the differential equation of the system, and we will take the Laplace transform of that differential equation, and these differential equations are then converted into algebraic equations, and these equations will have variables and constants. From the working knowledge of the system, input and output variables are identified, and the block diagram for each equation can be drawn. And this is the method that we are adopted nowadays, and each equation gives one section of block diagram, and the output of one section will be input for another section. The various sections are interconnected to obtain the overall block diagram of the system, and this is the basic rules for constructing the block diagram. First of all, we have to know the differential equation, and then we have to apply Laplace transform, and we have to convert it into algebraic equations, and we have to identify input and output variables, and we have to represent each equations with simple blocks, and later these blocks are interconnected to get the overall system. And let us construct a block diagram for an armature controlled DC motor, and that is problem 1. And we know that we have derived the equation for armature controlled DC motor in the previous class. Okay, I think you have gone through that section. And for constructing the block diagram of an armature controlled DC motor, we should have knowledge about its equations, basic equations, and the basic equations are usually the differential equation governing the armature controlled DC motor are we have we have studied it that in the armature controlled DC motor there are electrical section and mechanical section. The electrical section gives the equations VA is equal to IA into RA plus LA into DIA by DT plus EB. Also it gives an equation T is equal to KT into IA, and mechanical section gives the equation torque T equal to J into d omega by dt plus b omega, where omega is equal to d theta by dt, and in that case we have derived that T equal to J into d square theta by dt square plus b into d theta by dt. Instead of d theta by dt, here we are using b omega. Okay, and next equation is EB is equal to KB into omega, that is KB into d theta by dt, and omega is equal to d theta by dt. These are the equations, differential equations governing the armature controlled DC motor. And next we have to construct the block diagram. So that first of all we will go to the first equation, that is equation 1. And in that equation, that means we are taking the Laplace transform, so we will get the Laplace transform as VA of S is equal to IA of S into RA plus LA into S into IA of S plus EB of S. This is the Laplace transformation. And here in this equation, first of all we should have a knowledge about the system, what is armature control DC motor and all. And in this equation, this is equation number noted as equation number 6. In this equation, VA of S and EB of S are inputs and IA of S is the output. So if we have an idea about the system, then we can easily identify the inputs and outputs. So in armature controlled DC motor system, we know that VA of S and EB of S are inputs and IA of S is the output. So the equation 6 can be rearranged and the block diagram of this equation can be easily drawn. So equation 6 is rearranged in a manner that we get VA of S minus EB of S, both are input, so they are taking into one side. So VA of S minus EB of S is equal to IA of S into RA plus S into LA. This is by simple rearrangement of the equation 6. And in that equation we can find IA of S equal to 1 by RA plus SLA into VA of S minus EB of S, and this is the current equation. So VA of S and EB of S are the input and IA of S the output. So we got the equation for IA of S. So we have to draw the block diagram by considering that VA of S and EB of S are input and IA of S is output. If IA of S is the output and VA of S and EB of S are input, then we know that in the equation there is a term VA of S minus EB of S. That means the difference between these two quantities are taken. So we should remember that there will be a summing point with plus and minus sign, and its inputs are VA of S and EB of S. So that we will get at the output of summing point, we will get VA of S minus EB of S. So we will first draw the summing point with VA of S and EB of S as input, and output will be VA of S minus EB of S. And next that quantity will be multiplied with 1 by RA plus S into LA. So next will be a block that containing the term 1 by RA plus SLA. So that is the first block. Okay. So next we will take the Laplace transform of the second equation. What is second equation? Second equation is T of S is equal to KT into IA of S. So when we are substituting IA of S from above equation into this equation number 7, we will get T of S is equal to KT into instead of IA of S, what we are doing? 1 by RA into S plus SLA is substituting. So we have to draw it in a diagram. So that means that from this equation we can find that T of S is the output and IA of S is the input. So the next block after the IA of S will be KT. That means KT is another block and whose input is IA of S and output is T of S. So that is obtained from the equation 7. And next equation is T equal to, that is equation number 3 is What is equation number 3? Equation number 3 is T equal to J into d omega by dt plus b omega. That is equation number 3. So in the next, we have to consider next equation and we have to take the Laplace transform. So we will get T of s is equal to Js into omega of s plus b into omega of s. Okay, and this equation can be notated as equation number 8, and we can consider that T of s is the input and omega of s is the output. So the equation can be rearranged as T of s is equal to Js plus b into omega of s. That is, we can take omega of s outside and the input is the T of s and omega is the output. So we can write the equation for omega s as omega of s is equal to 1 by Js plus b into T of s. So this equation will represent the next block with 1 by Js plus beta inside the block, and input is T of s and output is omega of s. So that block is shown in the figure. And next we have to consider the fourth equation. What is fourth equation? Fourth equation is this one, that is Eb equal to Kb into omega. So we have to take the Laplace transform of that equation. So we will get the Eb of s is equal to Kb into omega of s. And in that equation, omega of s is the input and Eb of s is the output, and the block contains Kb. So the diagram will be like this. That is shown in figure 4. And next we have to consider omega equal to d theta by dt, which is equation number 5. And we have to take Laplace transform of that equation, that is omega of s is equal to s into theta of s. And in this equation, theta of s is the output and omega of s is the input. So we can rearrange this equation as theta of s is equal to 1 by s in omega of s. So the block diagram corresponding to this will be like omega of s input and theta of s at the output, and 1 by s at inside the block. So we got the blocks corresponding to every equations, and in order to form the block diagram, next we have to combine all these blocks, and we should have an idea about the input and output, so we can combine all these blocks. So first of all, we can combine the summing point and the block, and whose output is I of s, and this I of s will goes to the next block, and which is kt, and whose output is T of s, and this T of s then goes to 1 by Js plus b block, and whose output is theta of s. And next omega of s, and T of s goes to 1 by Js plus b, whose output is omega of s. And after omega of s, it is seen that omega of s goes to Kb, and its output is Eb of s. So it will be in the feedback path. Okay. And the next block is 1 by s block, and whose input is omega of s and output is theta of s. So it can be drawn like this. So this is the overall block diagram. So in this manner we can construct the block diagram. Okay.